All right, so this is the programming video for mill part 3. So Calypso open here, we'll go to create new measurement plan. And I'm going to import the CAD file for mill part 3. It is a step file, so make sure you have that selected down here in the list. We'll hit open. And once that happens, we'll turn to a solid model or a solid state here instead of a wireframe. And here is our workpiece. So for right now, a couple things I want to do. I want to go to measurement plan editor features, make sure you're in inches. And let's take care of our base alignment. So the base alignment we're going to use here is just going to be the lower left corner. We'll shift it later as necessary. So hit OK. And we'll go to spatial rotation and define select geometry and hit this top plane. And then since these other planes here are a little bit narrow, so they're somewhat unstable as a plane, I'm going to go in here and just define the line on a plane here. One there and one here. Okay. So our alignment is done. We'll hit OK. And then I'll just take care of my clearance planes now. I'll do clearance plane from CAD model. I'll set these to about 1/2 inch. Then hit OK. And then I will, I'm going to change Z minus, put that to 0, and then hit OK. Then hit no, make sure I always hit no here usually. All right, so now looking at, if I take a look at the print for this part, you'll see that we have a flatness tolerance on the top plane of 3 thou. So although it is a stock dimension, we do need to treat this flatness, as far as Calypso is concerned, to get the full, you can't just do necessarily a polyline around the edge. We do need to do some scanning on the whole top surface. So we'll get back into Calypso. And in this plane, we'll go to strategy. And we have some options here. You can guide it around with single points, or you can use grid. You can do multiple polylines. There's a lot of options here. So I'm going to go to grid. And that's not a bad measurement. It did actually, guess pretty well. You could tweak a lot of these. You could rotate the grid. It's up to you. One thing you could change is a distance for the edge distance. Maybe 100 thou, something like that. But see what happens. It tweaks us away from these ears, which we kind of want. So let's try 50 thousandths. Okay, that's not bad. I could live with that. All right. So I'm going to ignore the speeds and things for now. We'll leave them as default. But if this video doesn't run too long, we will get a little bit into some cookbook settings. So hit OK. And that is now taken care of. All right. The lines are all set. Usually lines default pretty well to a line auto path strategy. That is good. So right now we have a lower left corner. It's not a start alignment, but our base alignment. And that's really easy to set up for our manual alignments later on. It saves some time because if you look at the drawing, a lot of the specs on this are going to be coming from mid-plane. You take a look here, you got the hole locations are on these corners, these depths, right, all from this geometry, but the 0, 0 is going to be in the middle. We'll be checking everything out from the center, and then we'll locate the center features probably to the lower left to sync up that this part is in the center, if that makes sense. So we took care of this. We'll get back into Calypso and let's do a new alignment in the middle. So right now I'm just going to group these here, and this will just be base alignment. All right, and for right now what I'll do is I'll just define a line on a plane, and I'll take care of these over here. This one and this one. And your naming can get creative here, but this is a fairly simple part, so I'll take care of the lines just like this. So for right now, I'll add a transition into the video, and then we'll get into our next alignment. Okay, so let's get some features to use for our next alignment. We're going to draw some mid-planes or symmetry lines in the middle here to get the middle of these lines. Okay, and once we do that, we will have essentially 2 lines that intersect that we can use to position our new alignment. So what I want to do is I'll open all of these up for now so I have access to them. I'm going to go to construction, symmetry. Okay, symmetry is a theoretical feature. Feature 1 will be line 1. Feature 2 should be line up here, line 4 up here, so the y-axis. So hit OK. And then if we turn this hollow, you'll see the line. And the depth, I'm not really worried about. I don't really think it's in the middle is fine. I'm not worried about this part. So this is going to be the Y midpoint, something like that. And we can hit OK. Then we can do another one. So you can either copy and paste, or you can just go to construction, symmetry. And feature 1 will be line 2. And feature 2 will be line 3. And this will be X midpoint. Okay. And we'll hit OK. Alright. So we're good there. Now we can do a new alignment that is in the middle. So what we'll do is this will end up being in the characteristics. We'll go to resources, utilities, and in this alignment, the spatial rotation will still be plane 1. The planar rotation, now we can go to the Y midpoint. We'll clock it to the midplane. The X origin is the X midpoint. The Y origin is obviously the Y midpoint. And the Z origin will still be plane 1. There's our new alignment. We'll hit OK. Alright, and I can rename this as part center. And this is based off of the outside of the workpiece. So there's our new alignment. Okay. So now we can use this alignment to get the rest of these features. So I'll put a quick transition here, allow you to catch up, and then I'm going to end up going and taking care of, I think, the circles first. I think that'll be the easiest way. All right, so looking at the drawing, I don't want to, these holes are on center or concentric with the arcs, okay? If you look at the notes, they're all 1/4 inch. So 1/4 inch from this edge. So I really want to dimension these. I don't want to dimension them like that. I don't want to put, how aligned they are here. I would prefer to tolerance it from the center. I think that'll give, that gives me more information. Although the dimension is not necessarily on the drawing, I think that, working from the center definitely helps. All of these are split and based on the center anyway. So if we take care of that and treat them separately, all from this new alignment, it'll definitely make it a little easier to diagnose what problems are there and things like that. So that's what we're going to do. The other option is, again, that's what we'll do, the same thing with the arcs here. We'll locate the arcs that way, okay, to get, every single piece of data we need on this drawing. So, even into these widths, we can do 2.75, but then we need to locate it somehow. So we can do that as well, or you can do each edge separately, just, 2 3/4 divided by 2, and work it out that way. There's a couple different ways to attack this to get the exact data you're going to need to make sure the part is definitely in spec. So you have to take that into account. It's not, sometimes you're putting extra data in the report that may not be on the drawing because some of the geometric relationships in the drawing omit dimensions. Okay, so for right now, let's take care of these hole locations and diameters. Okay, so I'll get back into Calypso, and I'll get in here and just go to top view, and I'll kick it away a little bit. All right, so in features, okay, what I want to do is get some circles on cylinders. These are not positional tolerances from a Y14.5 standpoint, so we can just use circles. It'll just make it a lot easier. So I'll select all 4 circles, and then let's look at circle 1. So circle 1, take notice that the alignment is a base alignment. We need to update that to part center, and notice how the numbers start to make sense. Okay, so luckily, we're working with the model. The nominals are going to be correct to the drawing. Everything here looks okay. The strategy in circle path, we could tweak some of this later. I want to get through this before we get into the cookbook settings and get this running right and things like that. So for right now, we're okay. I want to output the X, Y, and diameter for this workpiece. All the X, Y locations are ±5. And I think, if I remember correctly, the holes, yeah, everything's ±5. the holes, except for obviously these widths here, so ignore that. But as far as the inner features, we're going to use 5. Our +8 diameters are +8 minus 4. So back into Calypso, it's going to be +8 minus 4. And the X value of circle 1, all that stuff is great. The key thing here is that circle 1 needs to be documented on the drawing as the upper left circle. We could call it upper left in features, but I think that's a little bit cumbersome because we don't have an this part is symmetrical, so we don't have an orientation for it. So we need to keep that in mind. So we could label these in the future, you know, as long as circle 1 is noted. If you put a Y positive on the workpiece with a Sharpie, whatever needs to happen to tell whoever, you know, what circle is out, then they would need to remember that, you know, if they're on a CNC machine, what they did. But as far as an inspection standpoint, that's none of our business. So we're good here. And this is what we're going to kick out. We updated the alignment, and we're kicking out characteristics for the X, Y, and diameter. So we'll hit OK. So now circle 1 is taken care of, okay? And we'll group these in a minute. But what I want to show you is, well, instead of going through each one of these separately, let's use something called the paintbrush function. So I'm going to select circle 1, select the paintbrush. I want to transfer from circle 1 the alignment, okay, and the characteristics. And notice when you highlight, it should show you X value, Y value, diameter. Then I'll go down here and select circle 4 to circle 2. Okay. Then hit OK. Now I want to show you that now we have all of those are kicked out. All of the settings are updated. Okay, so it's just a quick way to work through the list. In characteristics now, I will update this a little bit. Let's take care of circle 1, and I'll form a group. This will be circle 1. Same thing for circle 2. Could be hole 2, it's up to you, whatever you want to rename it. Same thing for 3. And lastly, circle 4. Okay, so we're good there. The holes are done. Okay, so next thing we need to do is let's take care of some of these outside 3-inch numbers plus or minus 20. So I'll transition here, allow you to catch up. We'll take care of those. We'll take care of this bottom plane here, and then we'll take care of this outside geometry. Okay, so let's take care of the widths of this part. I'm going to simply go into each of these individual lines, and from the base alignment, we'll kick out an X value plus or minus 20, and then hit OK. And then line 4 will be the Y value plus or minus 20. Now, one thing we need to be careful of that I just noticed is that we do have a clearance plane issue here, clearance plane Y. So before I would run this entire program, instead of checking everything individually, I will go into the measurement plan editor features, and I typically go into the stylus system and take a look. When you go to stylus, it shows you the clearance plane you're using with what probe. So if you're using a rotating head or a star probe, it definitely helps. But notice we do have a couple. There's one Y and an X. So if we go into travel clearance group, and we can set all of these, hold shift to select everything to clearance plane Z positive. Okay, so we're good to go there. Again, if you go to line 4, notice it's Z positive now. Okay, so in characteristics, we took care of line 3 and line 4 for the widths. We had the circles done. Probably not a bad time to do a simulation. So I will hit save, and I am going to go to the planner, turn the measurement plan simulation on, go to run, clear existing results, make sure you have third from the top selected to run your base alignment, make sure all characteristics is on. I put the run mode at normal, then hit start. And it should run okay, hopefully. Got a pretty good evaluation as far as full scan on the top plane there. All right, looks pretty good. PyWeb's working right now to generate a report, and it's going to be all good anyway because this is in simulation, so I'll just delete this. And so for right now, I'll hit save again just to be sure. And we took care of those two numbers as far as the length and width of the part. So I will put another transition here, allow you to get through simulation, save the file, all that kind of stuff. And then what we'll do is we are going to use a 2D curve to go all the way around this workpiece. And then we'll derive features from that curve. And I think it'll be a kind of interesting, smooth strategy to run the part, and a little different method to work on this. Okay, so let's create a curve that does this entire contour. So we'll go into CAD, we'll go to Creating Features. And then what we need to do is we need to section the model. So we'll go to Section, and I'm going to select this top plane. I'm going to change the normal vector to a 1. I lied, it's going to be a 0, 0, 1. Okay, and then I can move by dragging those icons or the corners over, and you'll see where it's going to section. So let's change the Z height. So we'll go to -0.1 maybe. That'll work right there. That's where the geometry for this curve is going to be. So that looks good. Okay, we will hit section, and you'll see the yellow line. Okay, so now we can go to point set. Okay, we need to create a 3D curve. That was my misspoke on that. And now we're going to generate the path from curves. Okay, so you need to go around and hold Control, and I like to select each piece of geometry as I go around. Again, I'm just selecting the yellow line carefully that I just created using section. And you don't have to do every single, we're going to do it and let this run real smooth all the way around the workpiece. But you don't necessarily have to. You can create individual 3D curves and analyze as you need to. So it's up to you what you want to create here. Again, this is very similar to just creating new features, but we're using the CAD model to derive a 3D curve. Okay, so everything purple is going to be the curve we're creating. It looks good. The edge distance we'll leave there. That's fine. You can change that. 4,000 is fine. The grid length, the distance, I'm going to end up changing that to something like, I don't know, 20 thousandths. Okay. Then if you create, you'll see the curve and all the points it takes. It's pretty good. You can get kind of crazy with how many points you take. If we get into here, you can tweak these settings, the point distribution, how it's curvature dependent. You can do all of that. There's a lot to this, depending on, if you're slicing an airfoil or something like that, trying to get profile of a line on different types of geometry. But you can mess with these settings. So even if we go like 0.5 and create, you can see how you can update this. So we'll go to 20 thousandths. I think that that'll be a happy medium. Usually when I do these, I will go for like 5 thousandths, but we'll live with that for now. Okay, so it looks pretty good. All right. And we'll hit create feature. Okay, so if we go to close, now we have a 3D curve. Okay, and the 3D curve is here. All right, so for right now, I'm just going to put a quick transition in, let you catch up. There's a lot of information very quickly. And once that's done, we'll go through and run this, and then we'll start deriving features from it. All right, so let's go ahead and run this feature. I'll just go into the planner, measurement plan simulation, and I'm just going to right click and execute the 3D curve here. You'll see what happens. It follows the whole profile. And then we'll be able to derive from those points taken, different features we want. So a couple things we need to do. These sharp corners are going to be an issue. Okay, we need the points around this. So if we open up the curve, you'll see the points, and I'll show you in a minute how to get all the points. These points guide the probe around.
So let's take a look at what is really going on here. So if we right click and go display measured points, okay, those are the ones that we just measured, okay, turn those off. If we go right click in here, okay, and we'll take care of show nominal points should be on. If we go into properties, okay, we want to check all nominal points, okay, hit close. There's all of the nominal points, the ones we want, the yellow ones, which are guiding it. The actuals are a little different. Then if we right click, we go to show point numbers. Now each point is numbered. Just be careful and don't select points like I just did. Okay. So get the strategy and get rid of that problem point. So now we can see the points around this. I'm going to go to wireframe again. And what we need to do is we need to leave these here. We need to take them out of the evaluation. Okay. So to do that, okay, we need to go to evaluation. We need to go to nominal vector direction and hit parameters. And then you'll see in the top, the selected points are not calculated. So when we select it, it just won't be calculated in the, for the curve when we derive points. So down here, we need to take care of, let's see if we go clockwise of these smaller numbers. Let's take care of, 69 through 72. Okay. So we're done through here in the list. So 69, hold control through 72. We'll go over here. We're going to go through 139 to 141. Okay. We'll take care of the next corner, which is going to be 240 to 243 roughly. I'm holding control the whole time. Take care of the next corner. Should be 310 to 313. Take care of the next one. 412 to 415. Next one. Holding control still, 481 to 484. Next one. It's going to be 583 to 586. And the last one here is going to be 653 to 656. Then we'll hit OK. And then hit apply and OK. So you'll notice now that the corners are blue. We do need to go back and make sure I get that one. Okay, I probably did not hold control, so I'll fix that quick. But notice they're blue, they're out of the evaluation. So get that strategy, go back to evaluation, get into these parameters, and then we are looking for holding control. 69 through 72 roughly. I hit OK. So now all the corners are blue and they're out of the evaluation. So again, you got to keep the points because the points tell the probe how to travel, but we don't want those corners in the evaluation. Okay. So we'll hit OK. And we are good to go now. All right, I will just double check in the planner, make sure this runs correctly so the evaluation is there. And again, I'm not getting any cookbook settings or anything crazy right now. When you go to actually measure a part, especially if it's critical, make sure you follow the Zeiss's cookbook on all your strategies, number of points to take, speed, all that type of stuff. It's very important and it helps cite your information on your decisions you make. So that did run correctly. So I'll let you catch up, get your evaluations right, make sure it runs right. Then we'll start deriving features from this curve. Okay, so let's start getting some features to measure from the point information that we currently have. So to do that, we need to go to features and let's construct a 2D line.
This 2D line, we're going to use recall feature points. It's derived from points already existing. We'll select the 3D curve. We will then highlight these two icons up here. One turns the points on, one turns the selection on. So what I want to do is window points here, hold control, window most of the points here, then hit OK. And you'll see we have a 2D line derived from those points. So this will be the y minus line. Okay. We will then hit OK. We'll worry about the alignment, other options later. Let's do the same thing for one of the arcs. Okay. So then we'll go, and actually I'll just do this line next just for a little bit of repetition here. So again, features, 2D line. This is going to be a recall feature points. Select the curve. Rotate this to an orientation that allows easy windowing. Select these points and hit OK. Now let's rename that as X minus Y minus line. Okay. Then what we'll do is let's do this arc next. So the features is going to be a circle. We will then go into options, recall feature points, select the 3D curve, select these icons here, and select the arc. Hit OK. This will be the X minus Y minus arc, or radius, whatever you want to do. Then hit OK. So you see what happens here. Okay, we took the points first, then are creating features based on them. So what we need to do is do all of the features around this workpiece. I won't make you watch me do that. So go ahead and continue doing this with some sort of labeling scheme. And then when I come back, I'll have all those done, somewhat organized, and then we'll start taking care of our characteristics. All right, so I got everything organized here. So let's take a look at some of the characteristics we need for this workpiece. Okay, here's our features. Okay, so we have the 3D curve, all the different X and Y features I have organized. In the characteristics, all I have is the information for the circles and our updated alignment. Okay, so for right now, what we need to do is let's take care of all of the radii on this workpiece. Okay, just something pretty easy. If we get into, let's open up all of our characteristics, or our features, I'm sorry, and let's take care of all of this. So for right now, what I want to do is, instead of going in here and changing something, I need to go to characteristics and just do a size standard radius for one of the features. So let's just go into the feature list and pick the first one, which is right there. Okay, so hit OK. It's 1/4 inch plus or minus 5 per the drawing. And then we'll hit, we'll actually call it, radius 1 is fine. The naming scheme is going to be somewhat critical. We can call it radius 1, that's fine. As long as we know that radius 1 here, then it'll go 2, 3, 4, whatever, and we could rename them later. But let's hit OK. And there's radius 1. Now what I want to do is, since we called out radius 1 using this one, if we go to our transfer, move the alignment just to characteristics for the XY radius, and then go ahead and we'll select everything below that as far as all the radii. And make sure we get all of them. And then hit OK. Hopefully we have a bunch of radii here. So there they are. Okay, and they're all labeled. Okay, the only problem is we did copy a couple of these. Notice any of them with 1 next to it. So go ahead and find any of them with 1 and just hit delete. That may not happen to you. Just be careful of that. Usually when there's 1 next to something, it's just a copy. And we just don't need them. Alright, so there's that. Radius 1. There's XY. Let's go through list. Here. There's a duplicate right there. I forgot that one. So we have that one, that one. That's because I had the other one selected. That was my fault. 1, 2, 3, 4, 5, 6, 7, 9, 10. There's another one I forgot. There we go. Okay. And your naming can change I'll leave this like that for now, and then I can just quick run this and see how it goes. Make sure everything works out. We're good there, and then I'll just close my pilot report. Okay, so the radii are done. Good time to save. Now let's take care of some of the other dimensions. Let's worry about the outside dimensions. Okay, and actually I'll group all the radii here. This will be all radii. Cleans up our characteristic list a little bit, look better on our PyWeb report. And now we can look into other options here for our features. So I'll leave the groups and features open. Let's worry about the, actually I'll close my LIDE. Let's worry about the outside of the workpiece. So if we look at the drawing, we have a dilemma here. To get the 2.75 number in the report, 2.75 does not locate this part on this part, but also this drawing does not tell us, is the outside the datum reference frame and the part to this, or vice versa? What is it? What matters to what? There's nothing there, and that's some of the issues with Cartesian coordinates. You don't know what's to what. So for the sake of this example, we're going to say that the outside boundary is 0 as we set with our alignment, our secondary alignment, and our primary alignment. They're all based off of the outside boundary. We'll compare all other dimensions in here, except for this one, to that 0, 0. Now, the 2.75 and the 1.250 are going to be interesting, because to get this width, you got not only give it a width, but some sort of location factor from 0, okay, because it is implied on midline to our shop tolerances and different standards that are listed in this top of this drawing. So this really, the best way that I think to do this is to each one of these features, or even these lines, is to dimension them in half. Now I know it won't match the drawing, but if you dimension it in half, plus or minus 2.5 thousandths, that will take care of the size and location profile of this. So it's kind of like profile of service, where it's bilateral unless otherwise specified. Because here's the deal, you know, we're talking about the 2.750, that can be shifted over this way, that can be shifted this way. Where is it in relation? And these lines imply a mid-plane or midpoint interpretation. So technically it's split. The profile is 5, you know, if this is plus or minus 5, okay, this is plus or minus 2.5 on one side. That'll take care of not only the size, but location tolerance. And that's my opinion on this component. If you have, you know, if you disagree or what your input is, I'm curious to see what people say in the comments. But again, that's one of the issues with, again, you know, with coordinate tolerancing. You know, what's to what? You don't know. So for this example, we'll just take care of this in halves. Okay. So we'll get back into Calypso. Let's take care of our 2.75 numbers. So for this, we'll get into, let's take care of our y minus features here. We'll go to this line, and this is going to have a y, or a, this line is going to have to the part center, okay, a y adjustment, if this lets me click, and y 1.38 is correct, plus or minus 2.5. This would be the y value for the y minus line. That's fine. Okay, so that takes care of location, and if you put them together, the width of the workpiece. So we will hit OK. Then we'll go to the next one. In the X positive features group, the X positive line, this will be from part center, X, last input, and X value, X positive line, that's fine. We'll minimize that one. We'll go into the next one, and we'll take a look at the Y positive line. If we change the alignment to part center, change or output a characteristic for the Y, 2.5, that's fine. And we'll do the last line here, the X minus features, the X minus line, a X from part center, and 2.5 is fine. Now, the one issue has the order in which I clicked that. We got to double check this last one and make sure we update the nominal to minus 1.375. The minute you tick that checkbox, it kind of sets that, so that's okay. So now that's set. So now we took care of the size and location for these. And again, it's not going to match the drawing nicely, but I think it's just a cleaner setup to do it this way. We could, you know, do a midline and tolerance the midline and then tolerance the width. But the problem is
you know, what are the tolerances at that point? Because let's say it shifted this way 3,000ths, and you know the size is a little bit smaller. How do you relay that to somebody? I'm curious to see what people say, but I figure if you treat it like profile of a surface, and again, we're assuming that the 0 is coming from the half of the 3-inch, and again, with coordinate tolerancing, that's all you have to assume. You know, if we treat it as such, I think it's a cleaner way to dimension it. So we got all of those. We're going to do the same thing for all of these widths in here. All right. I won't do that on video, so I'll pause the video here, let you catch up. Make sure you take care of all these widths the same way we did the other ones. Be you know, a y and an x, or y plus, y minus, x positive, x minus for each one. Make sure it's labeled accordingly. Then we'll come back once I finish that, and we'll take care of the depths here with caliper distance, and we have a depth from the top of this face down to here. And besides that, that'll be about it for this. Now, I only did, if you remember before, I just did all the radii for this example. Now, the radii, they are tangent here, but there can be instances where somebody wants to know the location of the radius. You're going to treat the radius like a hole. That is definitely something that is debatable. Do you want to not only give this a radius, but give it a location from the 00 at the machine? That's up for debate. It depends on what you need if the part is wrong. Sometimes if you're running these, and since the tolerance is somewhat loose, it doesn't matter. But you may want to, you know, somebody might ask for that. So there are different ways to interpret things. We're just going to use radii for now. And then we will, you know, continue this method of programming it essentially in half. I think that'll definitely help take care of, make the report cleaner. All right, so I'll put a transition here. I'll continue the widths in the X and Y separately, just like we did for the overalls of the 2 3/4. And then we'll come back in and do caliper distance for the depths. All right, so you see I put the 2.75 dimensions in groups, all the X and Y line locations from center. I also did the same thing for the 1.25s, okay? You'll see that if I go into features that, even like just this example here, that small line, I changed the part center for the alignment and just did a Y output, so they're Y 5/8. So there's our characteristics, okay? So now that those two were pretty much the same, the next thing I'm going to do is going to be some caliper distances. So I need to go to size, distance, and caliper. And the reason I need to do it this way is because in the drawing, it's from this line to this line is 1/2 inch 4 times. Okay. So for this distance, I'll go into here, and I need to select the Y minus line and the Y minus inner line. Okay. And that's going to be in the Y 1/2 inch, and it's going to be plus or minus 5 for this example. And this can be the Y minus pocket depth. Okay. Then we'll hit OK. All right, and then I'll just do another one. I'm going to do these separately on this one just to keep it organized. Okay, so caliper distance. And this is going to be the X positive line. And then the X positive inner line. That's going to be 1/2 inch plus or minus 5. And this is be the X positive pocket depth. Okay. Third one, size, distance, caliper. And then we'll go into the Y positive line, and then the Y positive inner line. And this will be a Y axis, plus or minus 5, and this will be the Y positive pocket depth. Okay. Last one, I'm going to save. It's going to be size, distance, caliper distance, and this will be the X minus line, and then the X minus inner line right there. Okay, and the X 1/2 inch, and this will be the X minus pocket depth, and that's okay. All right, so save again. I'm going to turn the part solid. Okay. There we go. And now we need to take care of the last dimension that I'm worried about here. The 375 will put a result element in. I'll show you that. We need to take care of this 200 thousandths dimension. So let's get in here. And let's create a plane. So define select geometry, click that plane, put this plane at the bottom. Now here's the deal, when we go to our strategy, we're just going to do probing points. Let's say here, 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 and here for now, just for this example. And then what I want to do is I want to leave it probing points, but I want to hop up to a clearance plane in between. I don't want to risk hitting the part. To do that, you need to move this clearance data. Okay, you could change the retract, but I'm not going to bother with that. And even the retract will be close. Let's just practice this way. I know that way we won't definitely have issues. So we'll go to copy, paste, paste, paste. Okay, so now in between each one of these, it's going to go to Z positive clearance plane. That is how we'll hop around. So we'll hit OK. We'll also kick out a Z value, plus or minus 5, I think it is. It's plus or minus 10, my mistake. So we'll change the tolerance to 10,000. And this will be the Z value of plane 2, so we'll hit OK. You look at our characteristics, there's our last Z value. And if you look at the drawing, I don't think I'm missing anything. We'll put the result element in a minute. That'll be a type-in dimension when we're done. I took care of the locations and size for all of these features and halves. I took care of the locations and size for the holes. I'll double-check. 3-inch should be double-checked. Just did the depths of those. Depth there, flatness. We do need to put the flatness in. Forgot about that one. That's an easy one. So let's take care of the circles. Circles have X and Y locations. We're good there for the holes. Let's take care of the flatness. So form and location, flatness. In the, not in that one, sorry, my mistake. In the flatness window, we will select plane 1, hit OK. And we'll just call it flatness 1, and the tolerance is 3,000. So hit OK. The last one is going to be a result element. That's going to be something we just type in later. So we'll go to features. Actually, I'm sorry, size, more, result element. And in here, we're going to end up putting this at 0.375, and we'll go plus or minus 20 on this. It is the stock size. It's not a big deal. I just want to make sure people use the correct stock. And then result element, this will be mic, or measure width of part, or height of part, or thickness of the part. Then we'll hit OK. So that'll prompt us at the end to measure this with a set of calipers so that our numbers go on a report. So let's take a look at this thing. Let's let it run now. I am going to save. Go into Planner, Measurement Plan Simulation, run, and let's run this thing. And again, it's not going to bounce around taking all these different features because we did it all with a 2D curve, or a 3D curve, sorry. And that 3D curve, we just derived features from using the points taken in the curve. So there's our holes. And then it measures this curve. And again, remember, we did get rid of the issues in the corners because the probe can measure funny there. So again, it's following that path, but those are eliminated from the inspection. So there's our, again, now it's just deriving the points. And it takes the 4, hops around, then again, it prompts us measure thickness of part, 0.375, then hit OK, and that's the program. Okay, take a look at the PyWeb report, and again, this is a good time. You'll see the groups. Okay, circle 1, circle 2. You'll see everything. Everything looks okay. From nominals, I do have to find the page. We'll go through. Everything looks good. The pocket depths are here. We could change this up so that the 1.25 dimensions are separate from the pocket depths. But that's up to you. That's not totally critical. So for right now, I'm pretty happy with this. I think it's a good place to stop. That was a lot to cover in one video. So if you have any questions, shoot me an email. And like I said, I'm anxious to see your comments. Again, this drawing, not being a GD&T, or a Y14.5 drawing, there's room for debate on what's important to what. So anyway, thanks for watching.